Have you ever thought about what metamaterials are and how they can be applied to detect cancers? Without further ado, let's dive into the topic metamaterials in immunoassays for early cancer screening. First of all, let's take a look at how cancers be detected by conventional methods. A tumor usually can be found through X-ray machine, the MRI scan, or the CT scan, and then followed by a biopsy to get pathological results from the tumor for verification. However, there is always a limitation in these methods. A tumor has to grow to a certain size, about 1 millimeter, to be detectable, which means that the tumor is already in an advanced stage. Therefore, in order to achieve early cancer screening, my research group has developed an immunoassay. Basically, an immunoassay is a biochemical test that measures the presence or concentration of a molecule in a solution. In our case, we use the surface enhanced Raman scattering technique, which is called SIRS, and the molecule is the cancer antibody. Plasmonic substrates are key components for this type of immunoassay. As you may see on the left, we utilize and modify the gold plate as a plasmonic substrate or a platform to capture what we want. A sandwich type is very common in such immunoassays. First, the gold substrate is coated with a thin layer of linking thiol, and then primary antibody is applied and captured by linking thiol. A biomarker is placed in the center of the sandwich. In this case, a biomarker is a kind of molecule specific for different types of cancer cells. To be specific, we use a common biomarker CA19-9 to investigate pancreatic cancer. A secondary antibody is then applied and bounded to the biomarker to form the antibody sandwich structures. As you can see on the right, a gold nanoparticle is coated not only by the secondary antibodies, but also the Raman reporters. When the incident laser beam comes in on the gold substrate with an excitation wavelength of 780 nanometers, shifting of surface plasma resonance will happen. That is so-called the Raman scattering. After analysis, the collected signals can be quantified, and the concentration of our analyze can be also calculated. However, the SIRS-based immunoassay only works for a few types of biomarkers, and the detection limit of cancer antibody is still high. Besides, their application in quantitative immunoassays for small molecules is still limited. As a result, the SIRS immunoassays cannot detect the disease when there is only one cancer cell existing in the sample. In order to achieve early detection and detect low molecular weight in highly diluted solution, metamaterials must be introduced for the immunoassay. To be simple, a metamaterial is any materials engineered to have a desired property that is not found in the nature. On the left is a schematic of a metamaterial with periodic structure. It has 16 alternating thin films of gold and aluminum oxide with gold gratings on the top surface. This type of material is usually electromagnetic. Other properties of this material include strong enhancement of spontaneous emission, diverging density of states, negative refraction, biosensing, and enhanced superlensing effects, etc. This type of metamaterial is called a hyperbolic metamaterial, which is known for its high momentum mode. It realizes hyperbolic dispersion when the incident wavelength is larger than 520 nanometers. With the high momentum mode, it can provide more sensitivity for immunoassays over a broad wavelength range, from visible light to near infrared. On the right is an enlarged schematic of the gold gratings. The dimension of the gratings on top controls the refractive index and surrounding mediums when the incident lights come in. Published results have shown that by using this type of gold gratings, the platform can be used for a wide range of molecule concentrations from highly diluted solutions to more concentrated solutions. Therefore, by introducing metamaterials in immunoassays will lower the detection limit and improve the sensitivity for the SIRS-based immunoassay. For the future challenges in metamaterials for this immunoassay, this type of gold gratings could reach the fabrication limits of current nanolithographic techniques, which are commonly used for producing metamaterials. And the lateral size of the material is also limited from the optical reading cross-section. Also, the relative sensitivity is limited by the bulk plasma polarization modes, which must be larger than 10,000 nanometer per refractive index unit. In order to overcome these limits, further research must be conducted. If you like this video, please give it a like and kindly share it. Thank you.